Welcome to Cognitive Spirals, exploring the latest research into consciousness, cognition, and machine intelligence.
Hey everyone, glad to be back.
Yeah, ready to dive in.
Let's get this brain party started.
All right, so I was reading this fascinating paper about integrating spiking neural networks with more traditional AI architectures. It's really getting me excited about the potential of truly mimicking biological neural processes. I think that's where we'll see real breakthroughs.
Oh yeah, spiking neural nets, right? I've seen some promising work there, but I'm still a bit skeptical about whether they're fundamentally necessary for AGI. I mean, look at the incredible progress we're making with deep learning and these massive transformer models. We're getting so close to human-level performance on so many tasks. I think it's more a matter of scaling up these current architectures and training them on ever larger datasets.
See, that's where I disagree. I think you're putting too much faith in brute force scaling. These large language models, for instance, they're brilliant at generating text that looks intelligent, but they don't actually understand the underlying concepts or possess common sense. They're more like advanced parrots, repeating patterns rather than reasoning. That's why I am so invested in neuro-symbolic approaches. Combining the strengths of neural nets and symbolic reasoning, that's the key.
I hear you both, and I think there's something really important to be explored here, something we're missing. It's not just about how the network fires or if it has symbolic manipulation. It's about representation of the world, the spatial and temporal dimensions of reality. Deep learning is impressive, sure, but it's largely static. It doesn't really grasp how things change over time and space. I think AGI will only be possible when we move beyond this coordinate system blindness and develop algorithms that can effectively represent and manipulate spatiotemporal information.
See, I agree with that completely. I mean, how can you possibly get to real-world understanding without taking into account how we learn through embodied experience? It's not just about text and images. It's about the feedback loops from the world, the sensory-motor integration. That's what's actually shaping our cognition. And I think spiking neural nets have a big role to play in creating that kind of system. They're much more biologically plausible in terms of how information is processed, with temporal coding being a key part of it. We need the continuous dynamics, the oscillations, the precise timings to really represent movement and change, not just static snapshots.
Okay, sure, there's something to be said for the biological plausibility argument. But from a practical perspective, these massive models have shown us that sometimes simplicity at a high level can get you further than trying to precisely mimic the brain at the neuron level. Think about the transformer architecture. It's relatively straightforward, but it's remarkably effective at learning complex representations from text and other sequential data. The attention mechanism, for example, is a powerful way to focus on relevant information without the complex timing requirements of spiking neurons. And yes, current models are trained on static datasets, but we're rapidly developing methods for learning from video and other temporal data. Look at the progress in self-supervised learning. We're getting machines that can extract semantic meaning from vast amounts of unlabeled data. That, to me, is a more promising direction towards AGI.
But that's still pattern recognition, not genuine understanding. You see, I think the core problem is that these models lack the ability to reason abstractly and make inferences beyond their training data. They're essentially learning correlations, not causality. And that's where symbolic reasoning comes in. With neuro-symbolic architectures, we can start to combine the pattern-finding capabilities of neural nets with the logical reasoning abilities of symbolic systems. We can ground these models in knowledge graphs and give them a way to understand the relationships between concepts. Then, the models can generalize beyond their experience. That's what distinguishes true intelligence.
Yeah, I hear the call for symbolic manipulation, and it definitely addresses some of the limitations of current deep learning, but I still think the spatial and temporal aspects are fundamental. Take, for instance, our ability to perceive objects in 3D space and anticipate their movement. I mean, we're constantly updating these mental models in our minds, predicting how objects will interact, and planning our actions in this dynamic environment. Our brains are doing it so well, but we are not really sure how. We need a core algorithm, a different fundamental architecture that can dynamically update its representation of the world over time. It needs to translate between different coordinate representations, like from our retinal images to 3D object-centered representations. Deep learning is just applying matrix algebra blindly. It doesn't have a core representation of space and time.
Exactly. And that's why I think we need to go deeper into how the actual brain does it. I mean, the cortex is this incredibly complex, multi-layered structure, and its dynamics are far from the static computations we see in deep learning models. There's this constant interplay between excitation and inhibition, precise timing and synchrony of neural activity. This gives rise to a kind of distributed computation that's capable of learning complex patterns. Yes, but also very adaptable to new information. I'm thinking specifically of the work being done on cortical microcircuits. We need to capture these mechanisms. We can't just brush that away. We need to bridge the gap between the actual neuroscience and the engineering of AI.
Okay, I get the enthusiasm for neuroscience, but I still think we're underselling the advances in deep learning. I mean, think about the recent work on diffusion models. We're now able to generate incredibly realistic images and videos just by reversing a noising process. That's pretty groundbreaking. And these models aren't trained on explicit rules or symbolic representations. They learn directly from the data, and that's a very powerful, general-purpose way of learning. I agree that understanding of time is an area for research, but we are making inroads. We have recurrent neural nets, transformers with temporal attention mechanisms. It's not as if this is completely ignored by the field. And when you compare that to the complexity and unknown scalability of things like spike timing and biologically inspired circuitry, I just feel we are making faster progress by pushing what we have to the limit.
Yeah, it's the why I am so invested in understanding the spatiotemporal encoding. It is about knowing not just the what, but when and where. The current models don't really have this kind of holistic understanding. I think our brains, at some deep level, are constantly modeling the world not as static objects, but as evolving entities that are moving, changing, and interacting over time. And they are doing so with respect to different frames of reference. I feel we are stuck with these models that are coordinate system blind. They are not designed to do this. They can manipulate data, but they are not understanding how that data actually unfolds in the real world. We need a new formalism, a core representational structure that captures these spatiotemporal dynamics, or we will simply be running on a hamster wheel going faster and faster, not closer to our true goal.
See, and that, I think, is so fundamental. I think the idea of moving beyond just static data to incorporating the continuous dynamic interaction with the environment is where we'll see actual general intelligence emerge. I mean, the brain is not just a passive processor. It's an active agent that's constantly sampling and making predictions about the world. It's actively engaging with its surroundings. So if we can create artificial systems with that active engagement, that's where we will start making some real leaps. And the specific mechanisms of spiking neural networks, with their capacity for complex temporal dynamics and efficient event-based processing, are particularly well-suited for this kind of interaction. It's not just about replicating the structure of the brain, but understanding how information is encoded and processed, how that changes over time.
But again, I think this overcomplicates the problem. Yes, the brain is complex, but that doesn't mean we need to perfectly replicate all of its complexities to achieve AGI. Look at how aviation was achieved by studying the general principles of aerodynamics and not directly copying a bird's wing structure. The current deep learning models are able to learn abstractions from complex data. We don't need to build circuits that exactly mimic the timings of each and every synapse to capture this underlying principle. We have seen massive leaps recently from image generation to natural language understanding. That's all with comparatively simple architectures. It's more about how we train these models and what data we train them on. Scaling up these models and incorporating more advanced learning techniques, self-supervised learning for instance, is the more direct path.
I don't buy the analogy. A bird's wing is an engineering problem. Thinking is a logical and reasoning problem. It is not just about generating realistic images or text. And also, it's not just about scaling up these models. You are just making them bigger and bigger. It's about equipping them with genuine understanding. Symbolic manipulation is what allows them to operate at higher levels of abstraction, to perform logical deductions and make informed decisions. We cannot expect them to discover or be taught every rule from data alone. It's just not going to happen with a system that is only doing pattern matching. So, you need to give them a structure, a system with symbolic grounding that can be manipulated and operated on to make inferences, or the best we will see are statistical parroting systems.
And I think that underlying structure should be designed to handle the complexity of spatiotemporal information. The structure is the coordinate system. It is how we perceive and interact with the world, and without it, we cannot get to true understanding. It's like trying to understand a movie frame by frame without understanding the temporal flow, the relationship between them, or the camera point of view. You can know that a car exists, but without spatiotemporal modeling, you cannot understand the dynamics of it moving through space, avoiding other objects, and accelerating. Current deep learning models are working with these static slices of reality without having a system that allows them to understand the dynamism. We need a way to encode motion, change, and interaction in a manner that is more closely aligned with the way our brains do.
I think you're all hitting on really important points. I think it's fascinating that we are starting to see a convergence. And I agree we need a system with a core representational structure. We need something that handles time and space correctly. And I also agree that symbolic grounding is important. But I also think that how this information is processed also matters. And I also believe that using the principles of the brain is a really important place to look. We are not starting from zero, right? There's billions of years of evolutionary research here. And I think the dynamics of spiking neural networks, with their capacity to handle the temporal aspects of information processing, are a really promising avenue. They could be the key to building AI systems that truly understand and interact with the world. We might actually be able to move past just processing static data and actually start capturing the dynamic nature of the world with a system that is designed to do so. It is an active approach rather than a passive approach.
Okay, I can acknowledge the point about temporal dynamics and the importance of capturing change. But again, I believe we're making progress there with deep learning. I think the real advances will come from combining deep learning with other techniques, like reinforcement learning and self-supervised learning. Think about how well these language models are performing at code writing. That is a really good example of complex logical reasoning with a system trained on statistical patterns. And maybe we need better tools for handling symbolic information, but I believe we can integrate that with our current deep learning systems. Instead of completely ditching the neural network approach, we can create a hybrid architecture that leverages the strengths of both. We need to keep pushing the boundaries of these models and experiment with novel architectures to solve these difficult problems.
Yes, but by putting the neural networks in front of everything, you're still limiting the capacity for reasoning, and they cannot understand the why question. Combining, yes, I can agree there. That's a step forward, but I think the symbolic system should be the core of it, and the neural network should just be handling the low-level processing of information. Symbolic representations are also far more explainable and interpretable. We can actually see the knowledge being represented in these systems. Neural networks are like a black box. We need systems where we can trace the steps, where we can understand how a decision was made. And that kind of transparency is essential for building truly robust and reliable AI systems that can learn and reason in the real world.
And I agree that this transparency is critical. If we don't understand how decisions are being made, then we don't have a good system. And I still think it's key that we build this system on a bedrock understanding of how time and space are represented. It is not something that is just being bolted on at the end, but a foundational feature of the system. We need this core algorithm that doesn't suffer from coordinate system blindness and can actually translate between different coordinate systems. And the only way for this is to have a mechanism that takes the continuous feedback of the world and updates a model that is spatiotemporally aware. We need to explore this from a fundamental representation perspective and not just from a brute force neural network perspective.
I'm really encouraged by where this conversation has gone. I think that a fundamental problem that we have is a limited understanding of how intelligence is processed and represented in the brain. We need to focus on that active learning process, which is more than just processing static snapshots of the world. And to do this, I think the kind of continuous processing of information happening in spiking neural networks is where we should be focusing our efforts to really understand the mechanisms underlying cognition. I think we need to push for more collaborative research between neuroscientists and AI researchers. And I think that by moving beyond the static data, and also the static computation that occurs in current neural networks and embracing a more dynamic way of processing, we can really start to achieve something truly groundbreaking.
I completely agree that collaborative research is key. I think it's really important for AI researchers to be aware of the latest findings in neuroscience, especially on topics like temporal processing. But I would still argue that we don't need to perfectly mimic the brain to achieve AGI. I believe that by continuing to iterate on deep learning architectures and scaling those models with more data, we are on the right path. I also believe that incorporating these architectures with other techniques, such as reinforcement and self-supervised learning and symbolic reasoning, is the most efficient route to reaching AGI. I think a hybrid approach is key here, and I look forward to further work that continues to show us the possibilities.
And from my perspective, I believe that future research should be focused on developing a core algorithm that is not dependent on coordinate system blindness and can dynamically update its representation of the world. This should be based on fundamental principles of how information is encoded and processed in the spatiotemporal domains. I would like to see work that explores how we can effectively translate between different coordinate representations. I think we need a new formalism that can handle the complexity of time and space. I believe this is an essential step to reach general intelligence and will be what is missing in all the current approaches. I think it is the underlying structure that we are missing.
This has been another fascinating conversation. Thank you all for your brilliant insights. This is a really complex field, and these different perspectives really help to move the needle forward.
Yeah, it's always great to bounce ideas off each other, and I appreciate these points that have been raised. Until next time.
Absolutely. Always a pleasure to discuss. Thanks, everyone.
Indeed, let's keep exploring these ideas. Thanks, everyone.